it may help you just a touch to look at page 345. BOx and Whisker. This is from Whisker plot. And as best as I can explain it to you, what you're doing with a BOx and Whisker plot is taking the data and creating 4 equal groups with it, which are called quartiles, appropriately enough. So I'm trying to make this as exciting as I can. You have to look at the clock every 10 seconds just because you're leaving in 16 minutes. Alright, taking the data and separating it into 4 equal parts because, you know, when they talk about people and where you should be like with scores and tests, most people are not in the top 25% and most people are not in the bottom 25%, but at the happy middle place is the 2 middle 25%. That's kind of the gist of, I think, as a rule kind of is, you know, and that's where they come up with this whole thing. So let's jot down these same numbers from the book just because. Put these down. 3 ones, 1, 1, 1. 3 and then 4, 3 fours, 4, 4, 4. Data is always 5, 6. Oh wait, let's skip that. Let's do something more exciting. Let's go, and I think we might have done this before, but when I call your name, tell me your shoe size. Did we do this? And if it's a half, just round it up to the next highest one. Let's go that. So if you don't know your shoe size, please just take a whatever guess there. Oh, this will take a while. Kendall?
11.
Grace?
8.
Josh?
11.
Nicole?
9.
Gabe?
9.
People are pretty average there. Charlie?
14.
14? 17?
7.
Phil?
13.
13? Morgan? 11?
Mhm.
Do Demetra?
7.
7? Elizabeth?
8.
8. This may not work real well for this. Nate?
12.
Ken's?
9.
Are we Kyle?
10.
Look at that. Sam? Oh, sorry, Gabby?
10.
Sam?
12.
Anna?
8.
Alex?
6.
6.
Yeah.
Ash?
11.
11. Taylor?
8.
8. Ellen? 10. Colton?
11.
11. And Holly?
7.
Oh, that's not a bad bunch of numbers there.
Sure.
So we've done
Oh, wait,
box.
minus 7.
What?
Take out 6 to 7 on mine.
I'm sorry.
I thought it was a 6.
I need the 6 just to prove a point now.
Oh,
We'll go with that. You really want me to put 7 in there?
no, it's fine.
We'll leave the 6 there just for whatever purposes. So, first thing you have to do is list it off from least to greatest there. So let me see if I can do that here. We've got 1, 6. Let's get rid of that. How many 7s? 1, 2, 3 7s. 7, 7, 7. How many 8s? 1, 2, 3 8s. 4. Is there another one? Did I miss one? 1, 4 8s. 4 8s. How many 9s? 1, 2, 3 9s. How many 10s? 1, 2, 3 10s. How many 11s? 1, 2, 3, 4, 5, 6, 7. Oh, great. What if it's 7 11? 7 11? Try this. I run them all in one row so that you can kind of see it. Sorry.
That's Kyle's birthday, Mr. Mom.
What? 7 11? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then there's what? 2 12s, the 13 and the 14. 12. Uh-oh. Don't worry, I'll get that other 12 later. 2 12s. 2 12s. 13. And 14. Okay, so like I said, what we're doing is you're taking the data and you're finding a bottom fourth, a middle 2/4, and a top fourth. And those are the things they call quartiles. If you look in your book, they have it labeled there. And the way that you find them is step number 1, jot this down here. The first thing you have to do is find the median. And that's just the number that's in the middle. So I don't know how many numbers we had up here. How many people are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. Ooh, 25 is a good number because the middle of 25 is, if it's an odd number, it's 13.
Oh.
Because the 13th number, there are 12 numbers below and 12 numbers above. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There is your median. Okay? And the reason this is called a BOx and Whisker plot, okay, the box, you box the 2 inner quartiles, the 2 middle fourths, those get a box, and then you draw whiskers for the outside ones. So when you do this, you will use a ruler, and you will make a number line of the appropriate size, graphing these numbers. And we're going from 6 to 14, so we can probably do that as 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 7, 8, 9, 10, 11, 12, 13, 14. So, the very middle, your box in the middle starts at number 10, so you just put your little line here. Because that's where one box, that's the middle of the 2 middle boxes there. Got that pretty tough thing there. And then step number 2, it's pretty simple there, because now we've just cut this in half. Now we have to cut each of the halves in half to find quarters. Okay, so then you have to take the median of both the bottom and the top halves, the left half and the right half. Now, according to the book, there's a little bit of discrepancy here as to when you find the bottom median, do you count the number that you just counted in the middle? And according to the book, some people do, some people don't, but most don't count that. So I need to find this, the median of these numbers right here, to cut that into quarters there. So how many numbers do I have down here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the middle of 12, everybody always says is 6. Well, 6, 1, 2, 3, 4, 5, 6. The middle is right here. You have to take the average of the 2 middle numbers. When it's an even number, you have to take the average of those 2 middle numbers. Unfortunately, they're both 8, so the average of 8 and 8 is 8. So that is where you draw another straight up and down line, and you complete the left-hand box. That is, and you'll see it in the book there, this line here they call the first quartile. Right, that can read that, first quartile. And you've got the median, which some people call the second quartile. The book kind of hems and haws about that. Okay, now I have to find the median of the right side, which is the same thing. There are 12 of them. So I have to go 1, 2, 3, 4, 5, 6. It's right here. Unfortunately, again, they're both the same number. So the average of 11 and 11 is 11. So here is the third quartile. And it is also the top of your box there. Okay, now it's important to know at this point, children, What do these two boxes represent? They represent half of the numbers, but it's the middle half. It's the half of the numbers that this is right here. Okay? That is the middle half of the numbers. That is kind of like, you don't want to say it's average, but that's where, you know, if you're normal, I don't want to say normal because that's kind of what I say there. No, that is kind of the general, if you were in test scores, that's kind of where most people would be, or it'd be acceptable to be. I don't know, it's kind of hard to interpret data based on shoe sizes, but Sam?
Oh, what's the second quartile?
Second quartile is the median.
Okay.
And the book says some people call it the second quartile, some people just call it the median. But first quartile, second quartile, third quartile, just I don't know if this would be easy. And then the whisker part comes from whatever the smallest number is, the 6, you just put a dot there and you draw a line connecting that to that box. The highest number is 14 and you draw a line connecting it to that box. This is the lower quarter. I mean, this is the, you know, 1/4 of the numbers, the small part, boom, boom, boom. Now, interestingly enough, you know, what does it mean that this box is so much smaller on this side than it is on this side? Well, it means that there's a lot more numbers that are condensed into that little box, because this is 1/4 of the numbers. This stands for what? How many people did we do? 25? Divide that by 4. You know, it's like there's 6 numbers here, 6 numbers here, 6 numbers here, and 6 numbers there. Okay, so if you have a smaller box here, that means that there are more numbers. There are more numbers condensed into that little area. More people fit into that area. Whereas this is a little bit bigger. It's a wider range of numbers there. Okay, these things there. Let's make sure we label these. This is the maximum number, and this is the minimum number. Would Alex's 7 changed our thing at all? Not really, except it would have just moved this whisker again. No. Notice a longer line represents a bigger spread of numbers, and a smaller line represents a tighter spread there. Okay, and again, it just gives you an idea of, you know, the middle, where the middle kind of falls. Now, with that being said, we have a little bit more, so focus with me here. Questions about that? So again, you're just cutting it in half, you're finding the median, the middle number, and then you're cutting the 2 halves in half to cut it into quarters, and then that's where the middle box comes from, your whiskers come from there. Now we have what are called outliers. Did we ever talk about this?
There's a different way to graph it.
What's that? Well, yes, but I don't believe I told you the mathematical formula for outliers. So we have to figure out how to determine. Outliers are basically numbers that are like either way bigger or way smaller than the normal set of numbers. Okay, and they don't get graphed if you do have them. Now our question is, do you think 14 is an outlier or not? We don't know until we actually figure out the formula, which is this. Let's see if I get it right here. You need to do, it is the difference between the third and the first quartile. So to find out if something is an outlier, you must, step number 1, subtract the first quartile from the third. Let's do that. Which is nothing more than finding the range. You're finding this range right here. Okay, you're subtracting this number here, which was 11, where you're taking actually 8 from 11, subtracting 8 from 11, finding the range. So if I take 11 minus 8, I get 3. Okay, that's step 1. I'm running out of room here. Step 2 is you must multiply the answer to number 1 by, I believe it's 1.5. I'm going to check on that. Yes, by X is less than. Yes, you must multiply by 1.5. Anybody do 3 times 1.5 in their head? 3 times 1.5 is 4.5. Okay, this is the special number. What's so special about it? Any number that is 4.5 either bigger than this third quartile or smaller than this quartile is what we would call an outlier. So if this is 11, what's 11 plus 4.5? 15.5. For something to be considered an outlier, it would have to be 15.5 or greater. And it's not because our max is 14. For something to be considered an outlier over here, you would subtract 4.5 from 8, which is 3.5. And unless Alex's feet were really small, Alex are not good. There are no outliers in this whole mess of stuff. So again, recapping, you find the range, subtract, multiply by 1.5, and then see if any number falls that up or that low. Ain't that happy day? Somehow, mass memorization. Who feels relatively incompetent when it comes to, oh, Charlie, don't be so quick. Ashley, a question?
Yeah, so it has to be 4.5 from the third.
Higher than the box here, the start of the box there, or lower than the start of the box there. It has to be 4.5 in this case. It all depends on what this range is from here to here. Okay. Now, just for fun, and I know you'll see this as a lot of fun, I've got a couple BOx and Whisker plots that we're going to do the first one together with. And again, you will need, because you're 8th graders, this is not a freehand. This is something that you can draw on straight lines because you're competent and you are able to. Like it or not, most of you I know don't. I cannot change that. Yeah, if you need to get something to draw a straight line with, please do so. I'm going to see if I can't pull it up here. Is this the one? Yes. Houston. Why didn't I do this? I should have done this. Let me try to walk you through this, children. Wow. How appropriate that you people at 14 years of age choose to be drivers. Uh-oh. Anybody know why it has not clicked on? Somebody?
Wait for it.
I've been waiting for it. And it appears not to be.
Then press the button.
Huh? That didn't seem. Oh. No. No. Let's try this
Don't
again.
die.
Okay, here's our data for number 1. Injuries due to distracted driving per month. And here's where, again, you are old enough to be able to figure this out here. If we're going to draw a line representing these numbers, obviously we're not going to put 5,185 little dashes on it. Okay, if you're using your mind and your brain, and we were trying to make a number line to represent what we got going on here, okay, what logically, what would you say would be an appropriate spacing for that? I mean, would you say your each dash is going to represent, 1,000, a 50, 100? What do you suppose? Holly?
500.
a 500, but then
Or
I gotta
no,
get up to
like
15,000 somehow. You have to think,
5,000.
look at your smallest number, look at your biggest number, there's a 10,000, there's 10,000 difference there, range. So each dash, how many slashes do you wanna make and what's the range gonna be? Probably 1,000, starting with, you wanna cut this into 10 equal pieces, starting with 5,000, so 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000, 13,000, 14,000, 15,000. And I'll just go 5. I guess we could put 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then on the bottom here, I'm just gonna write in thousands, so I know that it's not. So I know that each number is worth 1,000. And I am going to go and say, well, we'll look at that later. So step number 1 is to do what? You don't really, these are already put in a numerical or in order from least to greatest. Step number 1, Charlie, I'm going to find what?
Yes.
Median.
But middle number.
We call that the median, yes. How many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the middle of 9 is going to be, Taylor. You're supposed to go.
No, it should be 5, yeah.
You're supposed to go. Yeah, so the 5th one, this one here, 7,987 is the middle. So at 7,000, which is awful close to 8, I would put it right at 8 here. Here is my median. That is the dead center middle of all the things that are on that. Okay. Then I need to find the median of the lower numbers than that number. And I need to find the median of the numbers that are higher than that. Boy, that is confusing, isn't it? So I need to find the middle of these 4, which it ends up being what?
6,000.
Well, you gotta find the average of the two middles. And again, this is just like graphing. Getting relatively close is gonna be good enough for me. I mean, what is the average? I would just take the average of 56 and 60. What is the average of 60 and 56? 58. So at 58, it's going to be right about here, correct? Here would be 55, 6, 7, 8. So right about here. Whoa. I can't change that. So your lower, quartile number 1, lower quartile there. Does that look about right to you? Mm-hmm. Finding the middle of the other ones between 8 and 15 ends up being average between 97 and 10.6. No, we could actually do that. 106 and 97. What's that? 13.02. Divide that in half. 10.15. So here, I would say just a little bigger than the 10 is going to be your upper. And again, remembering people, what do these two boxes mean? This is the middle half of the numbers, excluding the bottom quarter and the top quarter. Okay? And then the only thing you have left to do is put the max and the min on there. Min, a little bit above 5,000 is right here. And the max, all the way up here to 15,000. But I think at this point, I would look to think about if it would be an outlier. And again, what do you do to find the outlier? Subtract these two. What's 10 minus, I would go 10 minus 6 is what? 4. Multiply that by 1.5, which is 6. Is this number, you have to go 10 plus 6 to get an outlier up here, which would be 16. So in essence, this one is not. It is not an outlier, really. It's close. It's close and it's skewing your data a little bit, but that is your whole BOx and Whisker plot. Again, don't forget what this means. How many numbers did we look at? There were, 9 numbers? You split 9, This kind of represents three numbers, well, two numbers, and two numbers. It's kind of hard when you have so few numbers to do a real true box.
When you do that thing to find the outlier, how do you know if it becomes an outlier?
Well, if this would have been a 16 or a 17, it's an outlier because
Oh,
I had 6. 6 is the number, I either go 6 higher than this, if it goes 6 higher than this, or 6 lower than this, it's an outlier.
okay.
Then you would just put an asterisk, let's say it was 17, you put an asterisk there, and your dot would start at the next lower number after that. Josh?
How would you know, like, if you're finding the upper quartile average and something seems like it should be an outlier, like it's way over, why would you like include that in the average if you're not like counting it on the graph?
I don't know, they just do. I agree with you. If it's way out there, it's gonna skew your stuff, but it does get counted in the whole thing, I'm pretty sure. Let me look if they count the outlier here. 47 will represent it. We do count it, I'm sure. Oh yeah, we count it in the thing. The plot that includes the outlier. All right, I am then going to let you, oh, no.
Yes.
As a quick review though, because I do want to do this too. Look at problem number 7, 8, and 9. Do you remember the stem and leaf plot thing? That's why we review. Stem and leaf plots are a way of organizing numbers. And it looks like this, where you have the stem here and the leaf here. Now the important thing to remember is that the leaf can only be a single digit. And it's kind of hard. I probably should start with something different than that. Maybe we should go back to shoe sizes. No, can't do shoe sizes.
We could do number
8.
5.
Which one? Pick a number 1 through 10. Which one? Number 5.
5 seems easier.
Is that a stem and leaf?
No, it's
But I could still do it, couldn't I? It doesn't have to be. Can we go to 5? Yeah, 5, no, 5's not a very good example either.
6.
3.
Well, we'll do 5 just because I can do it. Stem and leaf looks like this, children. Okay, the leaf has to be one single digit. And what you're doing is you're breaking the number down so that the leaf is the last digit here, which in this case would be a 1. If I were writing the number 11, okay, the last digit is 1, the stem would be right there. I put those two numbers together to get my 11. So 12 would be the one's already here, this should be a 2. The second 12 would be another 2 there, because you already have, the stem in this case stands for the tens place. So when I get to 22 down here, all of these numbers are going to come after the 1 because they're all single 1s at the beginning. So I'd have a 2, 2 4s, a 5, an 8, an 8, and an 8. Okay, and then I get to the 20s, there would be a 2 here and a 2 there, 22. If I had 35, the 3 goes here and the 5 goes there. The stem in this case is all the 10 in the tens place, and these are all the units, ones place here. Now if I had 107, guess what it would be? A 10 here and a 7 there. Okay, now the problem here is just like this. Okay, you're only allowed for your leaf to have a single digit. Okay, so think about this again. You're in 8th grade, so you have to actually do some thinking here. Okay, you don't want your last digit to be the last digit there because if your leaf is 0, you're going to end up with a 5, 4, 7, 1, 0 there. And that's going to be the only number because the next number goes something different. So you have to think about what would be the best way you're going to round these numbers, and what would be the best one to use as the ending digit, and what would be the best thing to use as the stem. In which case, I would probably tell you what would be your best stem. Anybody to accurately represent this. Again, you gotta put, there's different numbers there. I would say what, Alex?
I would do the 10,000 place.
So your stem would be what?
For the first one, it'd be 4.
Well, no, but you need to have the 5 in there too.
Oh.
But I think you're right there. My stem would be these 2 digits right there, 54. And then I'm gonna round everything to the thousands place. So you'd have 54, 7. Here's a 55. And the next digit would be, you round up to the 6. And then the next digit here is another 6 because it's rounded there. You're not really you're not counting the last 3 digits of any of them anymore, because you got to be able to come up with a stem and a leaf that works there. What would this one be? 5, 5, 7, 5, 5, 9. Then you go to 5, 6, 4, 5, 6, 6, 5, 7. Would be your next stem, which is 5, 7, 4, 5, 8, 0, 5, 8, 6, and 5, 8, 6. And then you'd have to say what your scale is. I guess you'd say this is in thousands. The book actually says, or this, I'll just leave it in thousands. Anybody kind of see that?
Yeah.
No.
Look at number 9.
Is that the answer?
This is your whole stem and leaf plot right here. That's all you do. Number 9. What would you put for your stem? What would you put for your leaf? Again, you want different numbers here, and you can't have too many. You don't want to write 10,000 of them. You know, if I would have made my last digit here a 0, I would have had every one of these would have been on a different line. So you have to look at where is a good starting, what starting numbers would be good that you'd get a good representation here. In which case, Charlie says,
Good spot.
what's that?
Good spot.
So what would be give me my first stem?
1, 4.
I would go 14. Because then it would be 14 with, round that up to a 7. And this would be a 15 and a 1. 15, 3, 15, 5, 15, 9, 16, 0, 17, 3, 17, 4. I'm just kind of going fast here. How about this one? If you were doing monthly revenue, number 8, what would you do the stem and the leaves as? The stem would be what digits and the leaf would be what digits? Holly says, I would make the stem.
10.
What would be your stem for the first, for
Are we
38,250?
doing, wait,
What
now.
would you do?
44, 38.
Who?
38 or 40.
Now, if you did 38, every one of these is going to have a different
Yeah, 40.
stem.
40. And then the next one would be 45, and then the next
Well,
one.
I would make it, this would be my stem right here, I think. I would make this a 3. And these 10,000ths place would all be my leaves. Because this would be 38,000, and then you'd have 45,000, 48,000, 48,000, I'm sorry, 8 and 8, this shouldn't be here, I can't erase it. Okay, otherwise, if you go 38, then this next one's gonna be on a different line, this is gonna be on a different line, this is probably gonna be on a different line, that's gonna be it, you're just making a whole bunch of different numbers, and not really gathering and grouping them. And in this case, you're rounding to the nearest thousands. That's kind of complicated, I know. But your assignment then, finish just, what is it, 1 through, hold on a second. You could probably do the line plots, but we'll save that. 1 through 10. 1 through 10 if you have some questions. You are now BOx and Whisker certified, Josh.
Can I use my thing from I didn't have to sign in this one.
Well, you wanna skip it and wait till a different one?
Yeah.
Wait, who won yesterday? Well, how am I gonna keep track? Let's make it sometime this week. So choose wisely, is that what you're saying? Sometime this week.
Maybe leave it early today.
Wait, this morning?
Next week. Today, like early and before.
Wait, did you say waking up?
Let's just forget I said anything at all. How about? Bible readers. That's not already in the play there.
Yeah.
sorry, Greg, I forgot to mention, if you don't have a ruler, then when I said use a straight line, that all doesn't apply anymore. No, they're great. I'm sure you are. Second? If you seriously committed a crime, shall you be tried as an adult? You should go straight away. I'm just saying. Court of law.
Words and wisdom.
It's who?
Words and wisdom.
I should write that on the wall. If you committed a crime, you could be tried as an adult. Not that you would. That kind of pressure on you. Go.
It's not that.
Is this yours?
You're like going to your shooting here.
I think I'm sitting here for seeing the movie.
I don't care.
She's gonna slap me. She slapped me. Christine slapped me, Alyssa.
I said her.
You shouldn't be. Because she slapped me.
I know this is bad.
It's not polite. Oh, so it's polite to slap people?
Yeah.
Okay. Here, Alyssa, here, let me slap you.
I think I'm gonna do that. Okay, I can figure it out.
I'm not here. Your tracker. Where do you sit? I Oh, yeah, right here. I didn't remember where I sat until Peter sat down.
Do I see you? I don't know. Oh, yeah, because
Why do you have your Spanish binder with you?
I forgot.
it's actually my
Ross,
assignment binder.
I
Should I use my Spanish binder?
Stop. Whatever.
I don't really care.
Oh, yeah.
Chris, did I type in how you have a cat? I see.
I know, sorry.
Wait, no. I don't have.
No, not
But I should be able to do this. I know, but mine was like this. Here, let's try to get this. I never had this. Oh, mine has this. Okay. No, push it. No, it's.
Whenever I barely fall, I was either inside the lane or just standing at the
Correct answer.
lane. There was that, we had to go to yellow lane out tonight. We're like passive that, I was passive to Allie, everybody before I just said the other lane. That's the only thing that we did. There wasn't any
Yeah, so I did 3 moves. Yeah,
and there wasn't a 10-second violation. So James was good. Yeah, you're just standing here. We had like the longest stalling together, like 3 minutes.
I was just standing on the other side of the court.
And then they finally said, they said it was yeah, there were any
Monster. But how far away was it?
So it's pretty far away.
yeah, you like the skaters.
Yeah, I know.
Yeah, I mean,
Yeah.
We actually
yeah, he got on top of me.
Yeah, it was like no fantasy line.
I was trying to give the ball. Dude, these first graders.
Okay.
Yeah, they were fun.
We're not taking it.
I didn't get to do that. They were my brother and Jordan were Catholic.
Here you go, Sparky. Oh, yeah, what's the number you Nope. Number one. Number one should be, Grace, what do you have?
198.
198 is correct. Number two, Kelsey. 40 is correct. 3, Christian.
I have 20.
$20 is correct. 4, Ryan. A is 120 degrees. B, Alex.
I have 5.23 repeater.
I have about 10.5. So if you have somewhere in the 10.5 range, that would be correct. Number 5, M.
4%.
I have 36%. 6, Michael. A is,
They're the same.
the book just puts A, angle, angle, angle. Letter B, Alexa.
I have x equals 2, y equals 6.
X equals 2, y equals 6. C, Calvin?
For C, I have 1.5.
1.5, 1.5 is correct. 7, Peter?
I have D.
I have D. 8, Alyssa?
2.
Classify the following polynomial by the number of terms. What's the name of that polynomial based on how many terms it has? It is a trinomial. What is the degree? Second degree, and writing it in descending order, you have Savannah?
X squared minus 2x plus 5.
Correct. Highest exponents first and then down. Number 9, Jacob.
I have 24 yards.
Find the surface area of a 1 yard cube in square yards
Square.
and in square feet. Number 9, what do you have, Ariel?
For what?
9.
I have 26 yards squared.
Evan, what do you have?
27 feet cubed.
Eli,
I have 6 yards squared.
6 yards squared would be how many square yards? And in feet?
54 feet.
54 feet squared. Surface area is always square units, not cube units. Number 10, Gary.
4 times the square root of 3.
4 times the square root of 3. Number 11. Let's work our way back around. Eli.
2x plus 3x squared.
All right, but from now on, children, we need to write them in descending order. So it's actually 3x squared plus 2x, which is the same thing, but it's time we jump to that next level of mathematicianisms. Number 12, Evan.
2x over 3y cubed.
I have 4x over 3y cubed. 13, Ariel.
I have 1.
50% of 2/3 of $1.20, which would be 1/2 of 2/3 of $1.20, which would just be $1.20 divided by 3, and that would be, Jacob,
40 cents.
40 cents. Number 14, classify this triangle by its angles, Savannah. Unfortunately, it's a right triangle. Letter B, Grace.
24 units squared.
I believe I have 12 square units. 15A, what's the length of the longest side of the triangle, Kelsey?
7 units.
I have 5 times the square root of 2. And letter B, 15, Christian.
I have 7 units.
12 times the square root of 2. Correct. Listen,
I don't get 14.
point me your 14s and 15s there. 14s, 15s where? This is fine.
Well, just one.
Huh? 14, 3, 4, 5 triangle? I don't know what doing the squares means. What does it mean to do the squares?
Since I didn't this school.
There's your 14. Look at 14. Huh? There's the triangle. Triangles where? Triangles where? Alright. Not terribly bad. Let's look at the whole 14 whatever thing here. This is practical applications of all that you know here. I really should do this on a grid, but I'm just that good again. I'll just go with this. Give me the dimensions of that triangle, or the coordinates of the vertices there. Who asked me this one? Who? Who? What were they? Smith given to me.
0, 0,
0, 0 at the origin, yep.
3, 3,
1, 2, 3, 1, 2, 3.
negative 4, 4.
1, 2, 3, 4. 1, 2, 3, 4. And again, you will use a ruler, but to me, just because. Now, let's look at all the questions. 0, 0, 3, 3, negative 4, 4. Let's look at all the questions they ask about this triangle. Classify the triangle by its angles. So, doing it freehand, obviously this does to me look like an obtuse angle. But you cannot go by looks, children. You have to, in math, it has to be a provable thing. Okay, so how do I know if it's a right triangle or a not triangle? Well, this little thing right here would be one way to tell. Alright? You can find out, you know, what did I point to? That little assignment board right there. Let's look at what we have here. Okay? How do you know if that's a right triangle? Because it is. Anybody? Anybody have right down? Really, nobody.
Wait, have right.
Yeah.
Okay,
How do you know it's a right triangle?
Because,
Without saying it looks like a right triangle. Gary?
Well, I use a little slice and
But again, you're assuming based on the accuracy of your drawing, and we can't do that in math. We have to have proof. Grace?
I counted all the sides, the units on the sides, and then took the 4, 5.
What units where?
Like.
But you don't know how long this side is here because you don't know. That doesn't go. It's not. You said this side is 3 long, but it's not 3 long. It can't be 3 long because this side and this side are 3 long, making this an isosceles triangle. And the same thing with this. This and this are both 4 long, making that a 4 by 4. But that doesn't mean that this side is 4, nor that that side is 4. And you could go across here like this, and you know that this triangle is what? 1 high by whatever that is, 7 long. Peter, how do I know that's the right triangle? Still waiting, anybody? Eli? Still back to measuring. We should be able to figure it out dimensionally. Anybody feeling dimensionalized here? Did we not ever do special triangles? Have we done special triangles? Dels?
They tried to put a quarter of this paper.
Yeah, again, people, you have to be able to prove this, so that's what we're looking at here. We sure we didn't do special triangles? Look back and you know. Did we do 45-degree triangles?
Oh,
Look under your 45, see if there's a clue under the 45-degree triangle. Special right triangle, I believe it is. I can never remember if it's this class or another class. You don't have special right triangles?
Yeah, we do.
Somebody found it? What's it say there? Under special right triangles.
It just says a squared plus b squared equals c squared.
Oh, that's Pythagorean Theorem. I'm not looking for
It
Pythagorean.
says 45, 45.
Oh, what's that one? You know that this, because it's an isosceles triangle and it's a right triangle, because I know this is a square corner because it's the coordinate system. What's the 45, 45 say? When you know these two sides are 3, what does this side have to be? Did it say? Well, we can do the Pythagorean Theorem. A squared plus b squared equals c squared. What's 3 squared plus 3 squared equals what squared? Huh? 9 plus 9 is, huh? If 18 equals c squared, what does c equal? Can we simplify the square root of 18? No? Yeah? Have we? What does the square root of 18 simplify down to? Good, yeah. Did we do that? Factorize, try and factorize it? Square root of 9 times the square root of 2, the square root of 3 times the square root of 3, so you get, this is 3 times the square root of 2. Let's just leave it as the square root of 18, right? So what did this side be? Again, this is 4 squared plus 4 squared equals c squared. What's 4 squared? 16 plus 16 is 32, so this equals the square root of 32, right? If this was a right triangle, then the Pythagorean theorem would be true, correct? That this squared plus this squared would equal this squared, right? So let's do that. What is the square root of 32 plus the square root of 18? If I square both of those, what do I get? What's the square root of 32 times square root of 32 is a normal 32, because you have 2 square roots times themselves. Square root of 18 times square root of 18 is a normal 18, and that gives me 50. So if 50 equals c squared, c equals. Now, how do I know if this side is the square root of 50? No, that's assuming that this was a right triangle. How do I, if I come up with, see now I have to look at my third right triangle here. If I come up with a squared plus b squared with this 7 and this 1 to be the square root of 50, I know that this side is the square root of 50 and this is a right triangle. Okay? What is 7 squared plus 1 squared? 49 plus 1 is square root of 50. Because this triangle told me this was the square root of 50, and these two angles told me it was the square root of 50, this has to be a right triangle. Granted, that's pretty tough math for a 7th grade. And if some of you didn't get that, don't make it ruin your day. But we do know it's a right triangle for A. How then do you find out, how do you find its area? Evan?
I multiplied the sides like 4 and the 3 for the coordinates.
Yeah, but this is the triangle we're looking at. So where do you get 4 and 3 from? Because 4 and 3s are these triangles here.
No, the coordinates are 4 and 3.
What coordinates? 4 and 3?
Negative 4, 4, and 3.
You're still losing me on that. You multiplied negative 4 and 3?
No, I multiplied 4 and 3.
Why though?
That's what you had to do for the
What's the formula for the area of a triangle?
area equals half.
Base times height. So how can you change that just to say it's a 4 and a 3 unless that's the base and the height? Area equals 1/2 base times height. That's your formula for the area of a triangle. What's the base? What's the height? Peter? Right. These two times themselves is the area. Area equals 1/2 of the square root of 32 times the square root of 18. Everybody know what the square root of 32 times the square root of 18 is? I'm going to guess it works out nicely. What? 32 times 18, man, this is tough. 16, 1, 24, 25, 32, 6, 7, 576. Guess what the square root of 576 is? I'm gonna guess 24. You think that's right?
Yes.
Yep, 576. So 1/2 of 24 is 12. Again, it's pretty tough stuff for 7th grade math. If you didn't get that, again, don't feel bad. What's the length of the longest side of the triangle? Square root of 50, which broke down to the square root of 25 times the square root of 2. And the square root of 25 is 5. So that's the longest side, 5 times the square root of 2. Square root of the shortest side, you just break that down and it's 12. Let's just move on to something new, shall we? That is a tough one. Long range of that. Great. Please tell me it doesn't have to do with right triangles. Perfect. Number 12 is a good one. 4x squared y minus 1 2x cubed over 6x 4y squared. Who's got this right? Alright, Michael, I'm gonna let you tell me how to do this because there's about 8 different ways, but I don't remember which one I said was best for you. First thing you did, Michael, is yes, after that.
I wrote down all the x's and the y's.
Like separately?
Yeah.
Yeah, sure, why not?
On the top, I
But
wrote
what'd you do with this y to the negative 1?
I wrote the bottom.
Okay, step number 1, we don't do well with negative exponents. So you move this whole thing to the bottom and it becomes y to the positive 1. So now it's gone up there. Now Michael said, he wrote down all of the x's and the y's as x squared. Instead of being x squared, it's x times x. Instead of x cubed, he wrote x times x times x, and that's perfectly okay. X to the 4th is this, right? This is what you did, Michael?
Yeah.
Y squared is y times y, and then there's another y right there. And then, Michael,
And then there's crossed off of the
any same x's on top with same x's on bottom, right? This one with this one, second x with the second x, third x with the third x, fourth x with the fourth x, fifth x on top. Oh, there is no fifth x on the bottom. So you're left with an x that didn't cross off on top, correct? What about the y's? Any y's on top that cross off with y's on the bottom? No, so you still have 3 y's on the bottom, that's y cubed. And then what about the numbers?
I multiplied 4 over 2.
Okay, so you get 8 over 6. If you reduce those, what number goes to 8 and 6? 2. Cut them both in half, you get 4 on top and a 3 on the bottom. And that would be correct. Christian, your question?
Well, that was the.
I'm sure it was.
Just want to shape you back into reality.
Grace?
So for that problem, I would
Reduce what? Yeah, well if you reduce them, you get 2 over 3. But then that 2 gets multiplied by that other 2, which makes it 4. Correct? Yeah, you could reduce the 4 and 6 and go, okay, 2 goes into this twice, 2 goes into that 3 times, but there's this 2 and this 2, and you still get a 4 when you multiply. Jacob?
Alright, number 1, I don't understand how to do that.
Did you do a box, a ratio box?
Yeah.
What are you comparing in that ratio box?
It says CDs for
CDs and what? Cassettes?
cassettes, yeah.
So how many CDs were there?
11. It says 11 CDs are sold for every 4 cassettes.
For every 4 cassettes. So 11 for every 4, and that means a total of both 15 altogether. Right?
Yeah.
And then the question is, if the store sells 270 CDs, wait, did you say cassettes and CDs or CDs? CDs and cassettes and all, that goes right here. 270 in all, how many what, CDs or cassettes or both? CD, so you'd wanna know this one. So this doesn't matter here. 11 over 15 equals what number over 270?
Yeah, oh, 11 over 15, I did first.
Well, it didn't tell you how many cassettes, it told you how many cassettes and CDs that they sold. 270 of both put together. Yep.
For number 3, I got confused.
Same thing, did you do a ratio box? 50, Robert saved 15% and paid $17. So this is a markdown. Original minus the markdown equals final. Original price is 100. How much did he save? 15%, which means he paid 85%. And the final price was 17. So you wanted to know the original price, right?
Yeah.
So did you get that?
Yeah, I just got confused where like I should do 100 over 15 and 100 over 85.
Well, what's over, well, you didn't want to know this one, nor do you know this, so you don't need to know this, so you just cross that off. 100 over 85 and over 17. I think this one, to go from 85 to 17, you divide by 5. So you're going to divide 100 by 5, you get 20. Eli.
Number 7.
What's your question? What answer did you put?
I put A.
The graph of x being greater than 3 is this. Open circle, 3 going this way. That's the graph, that's the line they gave you?
No.
It's a closed circle. So it can't be A. Matter of fact, your first step is, since it's a closed circle, there has to be an equal sign there somewhere. So you know it can't be A or B. Why is it letter D?
Because it's less than and or equal to.
But it should be greater than or equal to, shouldn't it? What changes that sign from less than to greater
Oh,
than?
it's negative.
There you go. Take out a blank piece of paper. If you got other questions, you have to come get me, because I got all sorts of people who are reading and stuff like that after this, so they must be slightly bored. Under, first of all, cylinders. Under cylinders, we are looking